My name is Fredrik Pettersson and I work as a Senior Application Scientist at Biolin Scientific. Today we're going to talk about QCM-D and what that method is. In all of our surroundings, behaviors of materials and products are strongly shaped by their surfaces and interfaces and the way molecules interact with them in ways we cannot really see. These ultra-thin boundaries, dynamic processes define whether a coating protects, whether a sensor detects, or whether a drug molecule truly works or breaks down during storage. QCM-D, Quartz Crystal Microbalance with Dissipation monitoring, is a surface-sensitive analytical technique that lets us follow these interactions at nanoscale in real time. Consider something familiar. A cleaning agent removing soil from a drinking glass or a piece of industrial equipment. We expect detergents to lift dirt and wash it away. But with QCM-D we can actually measure how molecules from the cleaner first swell the soil and then detach it from the surface, second by second. The everyday act of cleaning becomes a quantifiable surface interaction. Now think of a soft contact lens resting on the eye. On the surface of the lens, tear proteins, lipids and biological polymers form a dynamic layer that affects comfort, vision and the biological responses. QCM-D can track these layers as they form and change, revealing a complex molecular ballet on a surface we rarely consider in detail. Then there are systems where surface focus is less obvious yet crucial, such as electrodes in a battery or fuel cell. Here, electrode materials and ions in the electrolyte interact at the solid electrolyte interface to form layers that control efficiency, lifetime and safety. By mimicking realistic conditions, QCM-D shows how these interfacial layers form, grow, evolve and sometimes break down, offering insights that can help transform modern energy technologies. Across areas such as cleaning, chemicals and biointerfaces, as well as medical devices, pharmaceuticals and energy, QCM-D provides real-time insight into molecular interactions at surfaces and interfaces. It reveals how much material arrives, how fast it moves, and how rigid or soft the resulting layers become, capturing the full dynamics rather than just a single endpoint. From dishes and contact lenses to advanced energy storage materials, QCM-D reveals how these invisible stories are written on surfaces. By turning these dynamic molecular processes into clear time-resolved data, this surface-sensitive technique helps scientists and engineers design better materials and safer products. Reliable technologies depend on these interfaces that quietly shape our world.